Welcome back. A very good morning, good afternoon and good evening to all the participants and the students who are taking this MOOC course. And this the title of the course is Multi-Criteria Decision Making in an Application. And my name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. So, if you remember in the fourth lecture, we were discussing about the example number 6, which was basically to find out. First, the simple problem was to find out the minimization or the maximization of a quadratic function, which we denoted by f1, and I did mention there is a color coding there for us to understand. And then there was an object function 2 f2 with a different color combination, but the constraints for all nonlinear in nature. So, the first part in the overall emphasis in fourth lecture was basically to find out the minimization of f1 separately, f2 separately, and then try to find out the combined objective function its minimum value based on the fact that the objective function is now f1 plus f2. And using the diagram and also drawing and also with the graphs, we discussed that how the minimum point for f1, minimum point for f2 and the minimum point for f1 for f2. Minimum point means the decision variables x1 and x2 are all different, and also the objective function values at the minimum points are all different. So, we will try to extend that for the case when we are going to discuss about the maximization one. So, this is the continuation as I mentioned about the introduction part, and this is the fifth lecture under the title of the course, which we have already discussed. Coverage would be, as I mentioned, would be the continuation, and we will try to wrap up example 6 and then consider another example 7. Now, we try to maximize these functions. So, highlight, and as I go continue the discussion, I will highlight the points. So, we will try to maximize the functions. What are the functions? f1 is this, which we already know, I am not going to repeat it much. f2 which is this. Only thing, the center points for f1 and f2 are just interchanged. The constraints are similar, exactly the same. The first one was x1 plus x2 is greater than 60, which is same there in both the cases. x1 and x2 is less than 90, less than equal to 90. x1 is between 15 and 90, x2 is also between 15 and 90. Now, when we try to find out the maximization point, very interestingly the first objective function, which was f1, is satisfied and minimized at the point on the line x1 plus x2 is equal to 90, which is basically based on the constraint which I am trying to highlight here. The value of x1 and x2 excuse me, which gives me the maximization point on maximum point is 52.5 and 37.5 here, and the maximum value comes out to be 1462.5, which is 1462.5. Now, separately, if we do trying to maximize the point for f2, we do not think about f1 now. The interesting part is that f2 is maximized at coordinate system 37.5 and 52.5, which is just interchange with respect to f1 here. I will just highlight it. The point 52.5 which you see here when we are trying to optimize or maximize f1, and the point 37.5, 52.5 which you see here when we try to basically optimize f2 are just interchange in the sense the x1 and x2 coordinates are interchange. But interestingly, when we put that and try to solve and try to find out separately f1, separately f2, the values come out to be same, which is 1462.5 in both the cases. Similarly, as we found out in minimization case. So, let us consider the corner points. The corner points, say for these are examples which I am taking, and if it will basically illustrate why we are doing so, similarly as we did in minimization case. Let us consider the corner points 1575. Corner points means the corner points, if you see, which was obvious, I did not mention there. So, if I consider x 2 here, x 1 here, the corner points I mean are these. These were the corner points for the minimization case, which I am highlighting in black for the boundary. Obviously, once it goes inside the feasible region, the values of f 1 and f 2 will increase. So, obviously, corner points would be only that for the minimization case. The corner points which you are going to consider here now, which are marked in red, are these. So, 1575 would be this one, 7515 would be corner point this one. So, we will try to find out the maximization of the at the corner points for f 1 and f 2 separately. So, at the corner points 1575, which I am using a different color, say example green, just to highlight. So, consider this is B 1 and this is B 2. This 1 and 2 have nothing to do with the function f 1 and f 2, nothing, just they are suffix. So, when I find out the put the values of f 1 for the corner points separately, the value comes out to be 2025. When I try to find out the objective function maximum value for f 2 for this corner point 1575, 15 for x 1, 75 for x 2, the value comes out to be 3825. Interestingly, when I switch and I go from B 1 to B 2, so these are the B 1 corner points were here. So, B 1 led to this. When I switch to B 2, the corner points, as you remember, is given by 1715, and the values which we will get corresponding to f 1 and f 2, putting x 1 as 75, x 2 as 15, are very interestingly just interchanged. So, 3825 is the value of maximum for f 1, 2025 is the value for x 2 for f 2, and these values which you see, which are marked in green here for the corner point B 1, 2025, 3825, they have been just interchanged, and which highlights that the corner points would basically, if I find out the collective one, which I will come to later on, they would give me separately the same values. Now, the interesting fact would be that would that remain throughout the straight line x 1 plus x 2 is equal to 90. By the way, the points 75 and 15 and 1575 all both of them lie along the straight line x 1 plus x 2 is equal to 90. So, x 1 plus x 2 is less than equal to 90 is one of the constraints to basically find out the feasible region. Now, if you maximize the objective function f 1, and so let me use a different color as it was highlighted in the first instant. So, if I find out f 1 here and this was f 2 which is here, I am using the same color as it was given in the diagram simultaneously under the same set of constraints. Now, the common point which will give me the maximum value based on the fact we want to find out the combined objective function to be maximized, it comes out to be 4545. If you see, this 4545 is a point which will satisfy both the all the constraints obviously, and will satisfy the combined case such that we will get the combined objective function f 1 plus f 2 to be maximized. Now, trying to optimize the value for f 1 and f 2 separately, the coordinates are totally different. So, if I consider that, very interestingly, the value which comes out and satisfies both f 1 and f 2 combined is at 4545 is 1125. Now, if I try to find out, and this 1125 is totally different from the single objective function cases, as it was the case for the minimum case, minimum problem. Now, if I try to find out the values of f1 and f2 at different points, and I consider a set of points like, I will just highlight them. The first one which are given in the stars is 52.5, 37.5, 37.5, 52.5, 15, 17, 17, 70, as 15, 75, 75, 15. So, these were the corner points for x 1 plus x 2 is equal to 90, and one point being 45. 45 means what we have found out. If I do that, the maximum value which you will find out for the case when they are single, say for example, combining them and trying to find out the values for 52.5, 37.5 comes out to be 2475. Similarly, if when I interchange the coordinates, which is for the first and the second start point, the value of f1 plus f2 remains same, but the coordinates gets interchanged, and this is very much easily highlighted in the third and the fourth start point, which are the coordinates are 15, 75, 75, 15, and the values are 5850. But the last part which you see, that the value which we found out in trying to find out the maximum case, which was 45, 45, which we just found out, was coming out to be 2250, and this value, if you see, is separately the values of 1125 plus 1125, which was the maximum points separately for f1 and f2 at the points 45, 45. So, obviously, looking into that, the maximum value of 5850 is found out at the corner points, which is 1575 and 7515. If I draw the graph, again trying to maximize and we plot x 1 along the x axis, you could have done for x 2 also, which I mentioned in the earlier example, same example in the earlier class. And if I try to basically plot f 1 plus f 2 along the y axis, then very interestingly the maximum point comes out to be two corner points here. The values are 5850, 5850, and the coordinates are x is for this point, this point is 1575. X is basically a bold because it is a vector, not individual x values, and here also x value again a bold comes out to be 7515. They are just interchanged. So, the minimum case was the minimum we wanted to find out for the combined case. Now, let us go into the seventh and the last example under introduction. So, again this will not be quantitative, it will be more qualitative, but with also some additional factors quantitative in nature. So, the examples which I am discussing are basically to make one understand that the plethora of different type of problems we can solve under MCDM. Obviously, we would not be able to cover all the techniques, but we will try to basically go into many of them and appreciate the importance of them. Consider this case of Mr. Raman Murthy, who is deciding to rent a 2 BHK flat in the city of Visakhapatnam, and in doing so Mr. Murthy considers the following points. What are the factors on the points? The factors are 8 in number and they are as follows: primary cost, other cost, locality, community, safety, education, employment and entertainment. Under the factors, the reasons are given. Primary cost can be related to rent, electricity, maintenance. Other costs can be property tax, corporate tax, other expenses. Locality will be proximity to hospital, shopping mall, groceries, police station, schools, and so on and so forth. Community would be how conducive and how the locality is, whether they are friends, whether they are the people of the same age, same societal background, working in the same type of companies. Safety would be whether it is a gated community, whether the safety and that there is a low crime rate. Education, employment and entertainment would be based on how close the education institute is, where Mr. Raman Murthy's son and daughter would go, or his spouse would be working. So, employment proximity would be how far his or her spouse employment place is, how long it takes, what is the cost, going in a car, going a bus or a metro, whatever it is. And entertainment would be whether they want to visit the museum, the mall, go to the shopping plaza or go to the bookstore, and all these things are the factors which are important for Mr. Murthy. And the scale of measurements for these 8 factors are: the first 2 primary cost and other cost is in Indian rupees. The last 3, which is education, employment, entertainment, again is in Indian rupees, while locality, community, safety are given in a scale of 0 to 10. So, if I consider few logical values which are applicable for the city of Visakhapatnam and the localities are given. So, in Visakhapatnam I am considering the so called top 10 localities, which are Sitamadhara, MVP Colony, Gajuwaka, Madhuravada and so on and so forth in Pendurutti. And if I consider the factors which are given there, 8 in number, they are, I am again repeating, price, other cost, locality, community, safety, education, employment and entertainment. I am clubbing and I will come to that reason. Factor 1 will consider price and other cost for the house. Factor 2 would be locality, community, safety, which was given in the basis point of 0 to 10, and factor 3 would be education, employment and entertainment cost wise. So, the values which I have taken, which I am just highlighting, the column which I marked, which is under price or under other costs or education, employment, entertainment, are practical values which I found from the net. So, they are more or less, they would be obviously aberration, but they are the values based on which we will proceed for the 10 localities based on these factors. Now, what I do? I plot factor 2 and factor 1, which I have just highlighted in the 9th slide, and all the localities are marked. So, localities are marked by the points A, B, C, D, E, F, G, H, I. So, they would be 10. So, A to I. Now, if I consider factor 1 only, which is price, other costs, and I have multiplied with 10 to the power minus 3 in order to scale them down. There is no rocket science here, I just scale them down. And factor 2 was locality, community, safety, which was just combined weight of the factors, each individually being between 0 to 10. Now, if I consider factor 1, price, other costs obviously have to be decreased. So, if I consider on the locality J, which I follow accordingly, if you see the slide, there were 10 localities and they have been marked as I am mentioning A to J. A for the first one, B, C, D, E, F, G, H, I, J. J is the 10th one. So, this would be the first one according to the table, and this is the 10th one. So, I am only considering the 10th one. So, obviously, the analysis which I will do will be applicable for the others. So, factor 1 has to be decreased. So, it will goes to the left hand side as low as possible. Factor 2 has to be increased, better, higher the points, better for. So, if I consider all the sets of points A to I, A is so called best in the case that the level of factor 2 is the highest, but very interestingly cost wise is also the highest. So, a compromise has to be made by Mr. Murthy. If I consider point number F, so obviously F is very low on the factor 1, which is the cost, but obviously if I consider factor 2, which is locality, community, safety, it can never compete against H, which I am highlighting here. It can never compete against D, never against J or G or A. The reason I am saying is that if I consider in a two dimensional case, factor 1 and factor 2 go in opposite direction. So, trying to find out which is the best combinations between factor 1 and factor 2 for these 10 different localities in the city of Visakhapatnam has to be compromised in the sense that one factor increases, other factor decreases would basically give us Murthy a very good idea how he is going to balance that. Now, the second part of this diagram which I want to highlight are the dotted lines. So, there are three dotted lines parallel to each other, three dotted bold lines which are parallel to each other. So, if I consider, and they have been drawn arbitrarily in order to explain something. So, if I am based on any one of these dotted lines, so consider I am taking the dotted lines, the first one which is in, which I am marking, and I am taking 3 different points here, and I will mark them as, say for example, Z1, Z2, Z3. So, Z1, Z2, Z3, the overall value based on the fact that I am trying to find out the overall satisfaction level for factor 1 and factor 2 combined would be same for Z1, Z2, Z3. But individually the levels of factor 1 and factor 2 would be different for Z1 than with Z2 than to Z3. So, at what level at Z1 or Z2 at Z3 one would like to remain would depend on number 1 obviously the combined effect, and also on the individual factors based on which what is the level of satisfaction the person wants. Now, why these parallel lines? If I go to the other parallel line which I am now marking and I consider points Z4, Z5 and Z6. So, obviously, Z4, 5, 6 are on the same straight line. So, the level of satisfaction for the combined one for when I consider Z4, Z5, Z6 are the same, but interestingly the overall level of satisfaction for the combined one for Z4, Z4, 5 and Z6 are same, but the level of satisfaction for Z1, Z2, Z3 which is also the same are totally different from Z4, Z5 and Z6, which means if I consider the level of satisfaction for Z4 would obviously be equal to Z5 will be obviously equal to Z6, and if I consider Z1 which will be equal to Z2 which will be equal to Z3, the combined value if I consider for this one and the first one would never be equal. They are on a different plane, different level of satisfaction, like trying to have a different set of income. Based on that income I try to basically meet the needs. So, obviously, if I consider the bold parallel lines also, this is the same concept which I just highlighted, but why did I draw two sets of parallel lines, bold one and the dotted one? The reason being, in which inclination these lines would be would depend on what type of satisfaction level one wants to achieve and one wants to have based on the fact there are two competing different type of decision variables to be made. So, we will consider, I am just mentioning it very briefly, we will consider these type of indifference curves. Obviously, it is shown as a straight line, in many of the cases the indifference curves which are the bold one and the dotted one need not be straight line. Now, remember here we are trying to basically decrease F1 and increase F2. If I further on consider factor 1 and factor 3, where factor 1 is again price other cost again multiplied by 10 to the power minus 3 in order to scale them down, and the values of factor 3 which is education, employment, entertainment which was also cost multiplied by 10 to the minus 3 to scale down, and I again plot A to Z, A to J which are the 10 different localities in the city of Visakhapatnam. Very interestingly, now the scenario is a little bit different. Both factor 1 and factor 3 have to be decreased. So, obviously, in that sense point A which is locality 1 is highest both for factor 1 and factor 3 which is not wanted, both of them are increasing. if I consider, say for example, H on both the fronts F1, F2 and F3 are the minimum. So, obviously, we may be tempted to go for that. Now, why I mentioned this diagram which is shown in blue color, all the points and the bold and the dotted lines with respect to the first diagram which we just finished, is that in the first one there were two competing factors. Here the factors are not competing against each other. Now, also I have drawn bold parallel lines and dotted parallel lines. Again, they would also give you the concept of the indifference curves, which was much better explained in the figure 1, but we will consider such factors where both of them keep increasing. So, obviously, in the first case we consider one is increasing, one is decreasing, second one both should decrease in order to satisfy that level. We will consider in more details as we proceed. Now, why I mentioned these two diagrams is that concentrating only on factor 1 or factor 2 or factor 3 or a combination of any two may not give us the best result. We have to basically find out the best result based on the combination of all the three factors, which will come to that within 2 minutes. If I consider the scatter plot again, the third set of diagram which is shown in green color in the slide 12 for this lecture, we are plotting factor 2 along the x axis and factor 3 along the y axis and factor 2, which is locality community safety, based on the fact that higher it is better. So, more points would be better locality, and if I consider factor 3, which is education, employment, entertainment on the scale of 10 to the minus 3 in rupees, obviously that has to be decreased. So, again if I plot the localities from A to J, the same analysis can be done. Say for example, for F with respect to A, if they are competing. So, obviously, F would be lower on the factor 2 scale with respect to A, and if I consider the factor which is A is better, because A is giving much more locality, community and safety factors. But if I consider on factor 3, which is cost, F is lower with respect to A. So, both are pulling against each other, A and F. So, obviously, these concepts of the bold and the dotted lines of the indifference curves would also come into the picture. We will consider that again, I am saying in more details. Finally, when I plot all the three factors, which should be the case in a 3D plot, the red points I have not marked these communities of localities A to J, but it will give you a much better picture in trying to analyze that how you can basically find out the best solution based on the fact that Mr. Murthy has to find out a locality to stay with his family, such that his desire of trying to basically find out what is the best optimum point based on the 8 different separate factors. We combine them in order to in 3 factors in order to simplify and come up with the concept in a much clear fashion. So, with this we will end the introduction part in this 5 lectures which we have done, and slowly start with discussing all the nuances of MCDM, both quantitative as well as qualitative. Thank you very much for your attention. Have a nice day.